to take a look at the that last quiz that you guys just did before we went on our long vacation. We're going to take a look at problem number 1. I'll do some selected problems here. 2 sine x cosine x plus cosine x equals 0. Factor out cosine x. 2 sine x plus 1. Set each factor equal to 0. Keep the table from shaking. Alright, sine x equals -1/2. Ordered pair, something comma -1/2. Y is negative. Looking at underneath the x-axis, positions of 30 degrees. Puts us at 7 pi over 6 and 11 pi over 6. So x equals 7 pi over 6 plus 2n pi and 11 pi over 6 plus 2n pi. The first one's position where the x coordinate is a 0. This occurs at positions of pi over 2 and 3 pi over 2. But because they are 180 degrees apart, you can write it as pi over 2 plus n pi. Right, there's solutions for problem number 1. Let's see, let's do number 2. Cosine x equals cotangent x. I would probably go ahead and move cotangent x to the left-hand side. Cosine x minus cotangent x equals 0. Go ahead and use your identity to change this to cosine x over sine x. And find a common denominator. So sine x cosine x minus cosine x all over sine x equals 0. This is one of those few cases where you can actually multiply by sine x on both sides. And that takes care of that for you. And factor out a cosine x. Sine x minus 1 equals 0. And you're looking at something very similar to the last problem. Cosine x equals 0. And sine x equals 1. Alright, this is the same as we saw up here. So we're looking at something where the x coordinate is a 0. That puts us at positions of pi over 2 and 3 pi over 2. And remember that once we know that, we can simply write it as x equals pi over 2 plus n pi. And then for the other one, we're looking for positions where the second coordinate is a 1. And that happens to match up with pi over 2. Okay. So we're looking at, again, the same solution here, just for that one piece. We don't have to add any extra solutions to include this in the solution that we've already written. So this actually works for both pieces. Okay. Since we're writing everything in general solution form. Once again, problems 1 through 4 were in general solution form. Okay, let's do number 3. See if we can squeeze it in right here. Cotan x plus 1 equals 0. Check my camera and make sure we're still catching everything. Move it up just a little bit. Okay. All right. Move that 1 to the other side. And remember that anytime that cotangent is equal to -1/1, that means that tangent x is equal to the reciprocal of that, which also happens to be -1. So we're looking for positions where the tangent is a negative. That occurs here and here. They are 180 degrees apart. And that is positions of 1, 2, 3, 4, 5, 3 power 4. So I'm writing my solution as x equals 3 power 4 plus 2n pi. All right. We'll pause there for just a moment. All right. Let's pick back up with problem number 4. This is sine 2x equals -√3/2. There's 2 ways we can do this. We can do it either with the identity for sine x, which is sine 2x equals 2 sine x cosine x, or we can use u substitution and let u equal 2x, which is the way I'm going to do this one. So sine u equals -√3/2. And we're looking for positions for u, angle u, where the second coordinate is a -√3/2. That's a y value that's negative. Y is negative, so we're looking at things that are underneath the x-axis. And for us, the positions where 1/2 is the beginning is going to be our 60-degree positions. Okay. Those occur at, this would be our 1, 2, 3, 4 pi over 3. And this would be our 5 pi over 3. Okay. So our value for u is 4 pi over 3 and 5 pi over 3. If we write those as solutions for u, then we write them as u equals 4 pi over 3 plus 2n pi and 5 pi over 3 plus 2n pi. Okay. And then remember that for u is equal to 2x. So let's go back, put in 2x equals. And I'm just going to rewrite everything just like it is so you can see the whole process here. 2 pi and 5 pi over 3 plus 2n pi. And then we're going to divide everything by 2. Okay? Or multiply everything by 1/2. And that gives me x equals, and 4 pi over 6 is 2 pi over 3. And if I divide this by 2, it gives me n pi. And then here I'd get 5 pi over 6. And then again, divided by 2 gives me plus n pi. Right, pause there. All right, for this next set, 5 through 8, we are doing on an interval of 0 to 2 pi. Right, so for number 5, we've got 4 sine squared x minus 3. We're moving that 3 to the other side. We're dividing by 4. And we're taking the square root of both sides, which is going to be a plus or minus √3/2. So we're looking for positions on the unit circle where the y-coordinate is plus or minus √3/2. Let's think about where that would be. got to be positive or negative, up or down. So positions where we start with a 1/2 are going to be my positions of 60 degrees from the horizontal, or pi over 3 from the horizontal. So we're looking at pi over 3, 2 pi over 3, 3 by 4 pi over 3, and 5 pi over 3. And since we're writing our solutions on the interval of 0 to 2 pi, we simply list them. X equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And that's it for number 5. Done. Alright, I forgot to box the last one. There we go. Alright, let's go to number 6. 2 sine squared x plus 3 sine x plus 1 equals 0. If I get a minute, I'll come back and do number 4 with substitution with the identity for sine 2x. But for right now, let's go ahead and do this one. For those people who can see it and don't need to rewrite it, go ahead and factor this. If not, you're going to write this as 2x squared plus 3x plus 1. And factor, I think this will actually factor pretty nicely with guess and check, so we'll try that first. Got to be a positive 3. Okay, so otherwise you would simply immediately factor with signs. So 2 sine x plus 1. And sine x plus 1, let's double check, make sure that works. 2 sine squared x, yep. 2 sine x, 1 sine x is 3 sine x, positive, and positive 1. So everything's working so far. Let's set these equal to 0. 2 sine x equals negative 1. Sine x equals negative 1. And sine x equals negative 1/2. And that one's ready to go. Sorry. Hey, thank goodness I got some whiteout. Check this out. Here it is. Look at that. The beauty of whiteout. All right, so y values that happen to be have a negative 1/2. And that's negative, so we're down underneath the x-axis. So we're looking at positions of 30 degrees again. So we're looking here at 7 pi over 6 and 11 pi over 6. Okay. And then we're looking at y coordinates that are negative 1 for this one. Negative 1. And that's going to occur at this position only. And that's 3 pi over 2. Alright, so this is going to be one of our solutions for sure. X equals 3 pi over 2. And then we just have to write the other two solutions as individuals over here on this side for this equation, and we'll put them all together. So x equals 7 pi over 6 and 11 pi over 6. And we'll put everything together now. X equals 7 pi over 6 if we do them in order. 3 pi over 2 and 11 pi over 6. Let's pause.